This next section is about the discriminant. The discriminant is a new vocabulary word, and it's used to determine the number of real x-intercepts of a quadratic function. In the quadratic formula, you had a portion underneath the square root that was b squared minus 4ac. That is the discriminant. That value helps us determine what that plus or minus is going to look like. So if b squared minus 4ac is greater than 0, then there are going to be 2 real x-intercepts. If b squared minus 4ac is equal to 0, then there's just 1 real x-intercept. And if it happens to be less than 0, there are going to be no real x-intercepts, or 0 real x-intercepts. We'll learn in a future lesson that these are imaginary or complex roots. So we want to evaluate the discriminant and help determine the number of x-intercepts. I have this first example, negative 9x squared minus 6x minus 1. It does need to be in standard form for us to be able to do this, so if it wasn't in standard form already, you would need to convert it to standard form. Since this one is, I'm going to do b squared minus 4ac. B squared would be negative 6 squared minus 4 times a, that's negative 9, and c, negative 1. Evaluating this, you can use a calculator. You don't have to do that in your head. It's negative 6 squared minus 4 times negative 9 times negative 1 is 0. Since that's equal to 0, there would be there is one real x-intercept. This is not finding out what the actual x-intercepts are. The whole quadratic formula would be necessary for that. But this will just help you find what the nature of those x-intercepts are. So in B, same situation, b squared minus 4ac. We have negative b, which is negative 4. Sorry, not negative b, just b squared. So negative 4 squared minus 4 times a, negative 5, and c, negative 2. Put that in your calculator. You've got negative 4 squared minus 4 times negative 5 times negative 2 is negative 24. This is going to result in no real x-intercepts. There are 0 real x-intercepts. If we were to do the quadratic formula, the part that's underneath the radical is that discriminant. So in this quadratic formula, there would be the square root of negative 24, which we can't take the square root. That gives us a non-real number. That's why there are 0 real x-intercepts. So if you want to pause the video, go ahead and try C and D on your own, and then pick it back up when you're ready. All right, so if you did C, you did b squared, so negative 9 squared minus 4 times a, which is 3, and c, which is 4. Negative 9 squared minus 4 times 3 times 4 is positive 33. Since that's a positive value, there are 2 x-intercepts, 2 real x-intercepts. And then D, we have b squared is negative 7 squared minus 4 times 2 times 3 is 25. That's still positive, so there are again 2 real x-intercepts. So now you can use the discriminant to determine what the nature of those x-intercepts will look like for any quadratic function. You do need to make sure that it's in standard form first.